I think I should. I think I would like to start from the self-introduction, and then I will share the assignment details with the document. Okay. Could you see my slide? Is the keynote available to show?
Yes, it's now showing. Yeah.
Okay. Okay. Thank you. Okay. So, hi. Good evening, everyone. I'm glad to be here with so many motivated young people sharing the last course of backend session today. And my name is Liu Hanyu, and as shown in the Zoom, my journey to the into the world of backend development started from 2016. And unlike you all, I had very few experience during my college days because my major was not computer science. So I feel like this the tech immersion is a very good opportunity to join, to learn something from the industry from the college. In 2019, I joined TikTok in Beijing and focused on developing the advertising features in TikTok, and mainly about the some native advertisement videos in the For You page in TikTok app. And 2 years later, I transferred to TikTok Singapore in the social messaging team. For the past 2 years, I'm working on the development of TikTok messaging system. Yes, it is the IM, the instance message feature that you can find in the inbox tab. Yeah, I'm not sure how many of you use TikTok or use the IM in TikTok. Okay, by now you may have noticed that my English is not so good, and I'd like to apologize in advance. English is not my first language, so I'm still learning it. And this might be sometimes during this presentation that my expression might not be as clear as I'd like them to be. So I kindly request patience and understanding. And luckily, I have Matomi here helping me organize the question and Q&A part and communication with you guys in the chatting box. Thanks a lot. Every business value chain in TikTok has its unique business characteristics. So, for example, in my team, we are dealing with the huge high-level sensitive message data sent by end users. Of course, your messages, no matter in which IM system, which IM products, is definitely private and sensitive. So the data safety and the real time of the message processing is the most important things we care about. But in other business lines, for example, e-commerce business, the e-commerce cares about data consistency and data safety and stability most. In real world, you don't want to use lost money in any e-commerce products, right? So I'm saying that because I want to, I would like to see that we can't pursue perfect technology solutions that can solve all technical problems. So there's always some emphasis for specific specific business value chains. So instead, it's all about challenges to find the right solutions to match the current business requirements and solve the problems, maybe with the limited time and the resources. So basically, in this session, I will just introduce some high-level abstract technical concepts. I hope it can give you some preliminary understanding of backend technology and architecture used in TikTok, and inspire some of your interest in it. And but please note that I won't go into many deep technical details due to time constraint, and also I'm not allowed to review any closed source projects and on public technical knowledges here. But it sounds like the title of today's sharing is a bit of clickbait, and it doesn't have too much real architectures here in TikTok backend, but it is indeed from the real industry experience. So all those content is general and common. Okay, let's start from some fundamental concepts in software development. First, let's start with this quote. The design of programming language has always aimed to achieve two goals: to make programming easier and easier, and to fully utilize the hardware features and achieve higher performance when new hardware architecture emerge. So I think this quote reveals the essence of programming language design, and also the philosophy of backend development. Like designing a programming language, backend development is all about human efficiency and machine efficiency. Even it's hard to give a perfect example of solving problems through the best technical solution, but we are always on the way to pursue the better efficiency solution. And the machine efficiency actually is the performance we are talking about. So what is the performance from backend perspective? In general, the performance of a system is constrained of those two conditions, throughput and latency, and neither can be lacking. For example, if a system can support a load of 1 million concurrent users, but if the system latency is minutes or hours level, then the load of 1 million user concurrency is meaningless, because no one want to use a product like that. Can you imagine that if you open the TikTok, you need to wait 3 minutes to view the first video? No one will use that product. On the other hand, if a system latency is short, but the throughput is low, it is also not valuable, because you can't, even the product is perfect, you can't serve many users. If the user number increase, the system crash is unacceptable. And usually there is a relationship between those two things. The larger the throughput, the worse the latency will be. This is because if the request volume is too large and the system is too busy, then the response speed will naturally be lower. And the better the latency, the higher the throughput it can support. It's because a shortened latency means we can handle the request faster, so no more requests can be so more requests can be processed if the processing speed is quite fast. Okay, I will continue this part, and then we will take some time to answer the questions together. Okay, so how to analyze this and improve the performance on specific single program process running on the single server machine. This is very basic knowledge. I think you all learned it from the college lessons. And the bottlenecks are all about CPU, local I/O, network transmission bandwidth. And usually you can find the clues after doing some stress testing, performance profiling, and collect more technical metrics as much as possible. And those numbers, those statistics can guide you to make the right decision from all the possible optimization methods. And it's usually about trading the space for time, trading time for space. This part is more about utilize the machine performance as much as possible, and try to minimize useless code, useless code logic as much as possible, and that will reflected by improving the concurrency and optimizing the code. I know it sounds like right crap, and many people may overlook those optimization points, but usually it is usually the most efficient way to improve performance, because you never know how many repeated logic code execution and the duplicate memory and storage wasted in a program, especially in a big and complex program or system. And okay, next let's step out the single machine system, and let's look at some distributed world. When we expand the topic to large scale distributed system on a global scale, we need to consider more system bottlenecks issues. And first is the balancing. The balancing issue is how to evenly dispatch the requests to our computing resources from all the end users all around the world. And yeah, it's a simple concept, but it's a very, very important component in a distributed system. And next is the RTT latency, which is the round trip time latency. Actually, RTT is a physical limitation. When the physical distance between the data center and the user, or data center and the data center, between data center and the data center, if the distance is far, and then the delay of the optical communication becomes an unavoidable problem. And we all know that the speed of light is 300 million meters per second. You guys can guess how far is the distance from Singapore to New York? Someone can try to answer it in the chat box. I think this is a real question.
100 kilometers.
Okay, there are
more answers.
Yeah. Okay. There are yeah, the last one is correct. Is over 50,000 kilometers. Yeah, I think this is a real question that Google can answer it faster and accurate than ChatGPT. Yeah, distance of 50,000 kilometers. At this distance, even the optical, it takes more than it should take more than 50 milliseconds for the light to travel, right? So yeah, we haven't mentioned the other network overheads, like the fiber optical converter, or some other network protocol overheads is already 50 or even hundreds milliseconds limitation, physical limitation. So that will definitely a problem. And the next is the transmission link quality. So this diagram here is just is an example of a submarine cable system in Asia Pacific region. It indicates that Singapore has a great advantage in the field of the network communication, right? Because it's a hub for so many cables. The concern is if the communication quality depends on so many undersea cables, and as the distance increase and many cables are involved to support the communication, then the probability of encountering a failure also increases. You never everything will may happens. For example, some shark bite the cable under the sea. It's just a joke, a example. Furthermore, the problems caused by the cable failure are not. It is much severe than other network issue, because it's not just the impact the some users to link to the data center, but it will affect the communication between data centers, which makes the impact much more severe. Yeah, so and the last part is considering we have to use multiple data centers to support this large scale business, handling data from all the users across the continents. Then the data consistency across regions becomes much difficult, and it will be there will be a lot of trade-offs if a product wants to serve more people across continents. Okay, before I move on to the next part, I will answer some questions. Okay, first, how do TikTok manage the high volume in the architecture? Which one will you know which to use? Sorry, I don't understand your question here. What you maybe you can add some more context about the question by submit another one. Thanks. What happened to TikTok if the data center down? Good questions, and I will also mention that in the following section. The high availability and or the disaster recovery is always a critical and crucial topic in our daily development work, and we do have a lot of mechanism and solutions for different kind of disaster recovery. And usually, as you may know, that we do have several data centers. Actually, currently we have 4 data centers across different continents right now, and there will be more on the way. So usually, if we are talking about huge data center failure, we will have another data center as backup. For example, we do have a data center in Singapore, and also we just built another data center in Malaysia. So if Singapore data center is down, the users in Singapore can access the Malaysia data center to use the TikTok product seamlessly. Okay, which cloud system does TikTok use? Is it located? Depends on us. Okay. Right now we use our own data center cloud or the cloud service in most countries or regions, but we also use a lot of third-party cloud service provider, like we used the AWS before, and also we are still using the GCP, the Google Cloud Platform, and you may know that in the US we use separate we use a special cloud provider by Oracle. So the platform is not is dynamic, and we use a lot of combinations. And does TikTok have their own server? Yes, I mentioned that we do have we built our own data center with our own server machines. So the data center is not by other companies like. Repeat questions. When does TikTok decide to scale horizontally and scale vertically? Good question, but it depends. TikTok is a huge. It's not just one system. It's a huge system combined with a lot of different system from different business value chains. And if we are talking about different components or middlewares in this architecture, they have different elastic expense solutions and high availability solutions. It depends. Why do we need multiple data centers instead of just using CDN, Cloudflare? Okay, actually CDN is just a cache system for statistic content, but it can't cache everything, right? In fact, if we are talking about the dynamic data, for example, it's famous that the TikTok recommendation authorization is quite good. That's because we use your all your user action occurring in the app to help the algorithm to guess what you like next. So this data is definitely dynamic and is occurs and produced and used in real time. So that kind of data can be cached by CDN. Yeah. Then if, for example, the data center in Singapore down, then when using the Malaysia data center, the used TikTok content will be mostly seen in Malaysia content. No, actually, this is a good question. Actually the data center has no. It's just you can treat it as just another cloud platform based on another physical location, but it doesn't mean that physical location can have a strong relationship with the user data or with the product content. So we only have countable just several data centers, but we serve in 200 countries and regions. So that is the data center is not limited to the region content. How do TikTok deal with latency, especially with increase in number of content and users? Will there be product that you guys know which products to use, or is it just a one size fits all method? I'm not sure I understand your question accurately. Yes, the content, the data volume is increasing, and also our user number is increasing. But yeah, we do need a lot of development work for the elastic issue. And I don't know what does the product here mean. If we are talking about the technical stack here, I would say that you will find any of the public or open source technical stack used in TikTok at some corners, because this is a huge company with a lot of engineerings. We always try. There's always a team trying to use a new tech stack or new solutions to solve their own business requirements. So you can almost find all the open source projects, and also we build a lot of our own closed source middlewares to support the huge number of data volume and users. Using multiple data centers to essentially ensure data resiliency, accurate accessibility, right, is the events of failure. Yes, yeah, in short terms, yes. Does TikTok utilize concepts like sharding by country, regions? Yes, we do use sharding. We do use sharding strategies, but usually not by country or region, or at least not all of the business scenarios is sharding by country and region. But of course, for content discovery, the country and the region, of course, is a very important factor. How do TikTok know which data center to be bringing information to? For example, if there's one in Singapore, one in Malaysia. Okay, good question. I think I will answer it by the next session. Yeah. How do we start a new page to code? How do we start a new page to code? I don't know. We have a pagination in coding. Sorry, I don't understand the question. Well, TikTok access my Wi-Fi. I think it's a joke, right? Of course, no. Yeah. Okay. I will continue first, because I think many of the questions can be answered by the next following section. Okay. Here are some facts in TikTok. So we are serving users in about 200 countries and regions. I don't remember the exact numbers, but this is almost all the countries and regions in the world. A fun fact that we don't serve two countries in the world, and those two countries just it's just happen to have the most population, which one is China, one is India. And as of September 2021, we got our 1 billion users access TikTok monthly. And yeah, I don't know the real-time number, but as of September 2021, we already got 1 billion MAU and also 1 billion view times daily, which means that the concurrent requests from end users are in, I think it's in terms of millions range. And the number of microservice in the TikTok is also very huge. It's in the thousands level, only to support the TikTok features, not count the infrastructure service in. Yeah, please note that all those numbers are not real time and only intended to intend as rough reference. They're all from the public media sources. You can find more latest news and the numbers from the official TikTok newsroom website. Yeah, I just want to say that the concurrency here and the data volume here is quite huge, considering we are a UGC system. The most actually I can say is one of the most popular UGC system in the world. So in addition to the common technical challenges in the industry, TikTok will also face some unique special non-technical challenges. Yeah, here I just list some common challenges we have. First is the repeatedly iterating features. Actually, we still release a new version of TikTok every week. So the iterating features, the new feature releasing is quite fast. And I mentioned that we do have massive data because the user number is so huge, and we're serving all the continents in the world. And unlike for most of the famous network products like Google, Facebook, Apple, they all serve users all around the world. But you may notice that in different products, the requirement for data syncing cross continents is different. For example, if we are talking about Google, the search engine, if you access the Google search engine, it might be it might focus on the content which is suitable for your country or for your language. So the data is not so so important to syncing across the continents or cross data center. But for TikTok, like some communication apps like WhatsApp, they must it must sync data, sync public UGC data cross countries, cross continents. For example, in Singapore, you still have opportunity to view the videos which is popular in US, right? So which means we must handle massive data cross data centers, cross continents in relatively real time. So this is a bit unique, is a bit special from some other popular products. And the last one is the geopolitics. Yeah, someone just asked, does TikTok access your Wi-Fi? Yeah, so you guys may have heard about the US congressional hearings where our CEO, Zhou Shouzi, the CEO of the TikTok, was questioned about TikTok data politics, especially in the US. We not only isolate the data of US users, but we also need to isolate the whole system operations, which means that our non-US engineering colleagues cannot directly operate US data center. So we can't touch anything deployed in the data center in US. And this is quite a special engineering challenge for this such huge system. I think not much companies faced this challenge before, and this requires us to consider the compliance issue and engineering collaboration efficiency as much as possible in our engineering design. So we need to find a way to enable non-US engineers to cooperate more efficiently with US SRE. This goes this poses the great challenge for designing a efficiency SIE system and data protecting system. So how does TikTok handle it? In the next section, I will introduce some common technical concepts in large-scale distributed system to give you a preliminary understanding, and all those technicals are widely used in TikTok. Since this part is mainly about some technical concepts which you can learn from your colleague courses, so I will walk you through it a bit faster and try to answer more questions if we have time. First is about load balancing. I just mentioned shortly before, and it's LB is the process of dispatching the workload among multiple servers to improve the performance and avoid overloading, especially overloading on partial on single server. Yeah, there are different types of load balancing, mainly divided by the layer 4 and the layer 7 LB in the OSI model. And layer 4 LB operates at the transport layer, and it's incredible fast, and it's able to proxy large amounts of traffic without expecting request content. And comparing to layer 4, layer 7 LB is much flexible. It makes routing decisions based on the application level information, which means it needs to pass the packet content. So it do have some performance cost, and it support that flexibility at the expense of speed. I won't go into details here. If you are interested in the Linux kernel or network protocols, studying the load balance implementation is quite a good entrance point. So it's a good start. At least here is a good layer 4 load balance open source project you can refer to. Okay, next is about data replication. So data replication mainly serves two purposes. First, it improves the reliability and robust of a system by creating the data copy, the redundancy. And secondly, the data replication allows for data to be located closer to the users. So it's, of course, is good for the performance. Usually, I list the data mirroring and the sharding here, but mirroring is making sure that all servers have the same data. Yeah, that's the purpose of data mirroring. And data sharding is splitting data into small chunks and storing them on different servers. So strictly speaking, data sharding is not replication, but is the key aspect of the distributed storage. And combined with load balancing technicals, so we use LB technicals to dispatch the data into different sharding, so that we can achieve the elastic horizontal scaling. But just data sharding cannot solve the problem of data loss. If a single machine failure occurs, some data stored on that machine may be lost. Therefore, data high availability it can be only achieved through the redundant data storage. So we still need the mirroring. And however, adding more machines to have to copy the data to make our data service high available. It also makes our data service very complex, especially when it comes to the transaction processing across servers. And the data consistency issue will be a big problem with the complexity increased. You will find many trade-offs in dealing with the data system. A typical trade-off is the CAP theory. It contains three properties, and firstly is the consistency. The consistency means that every read from the database will always return the most recent written data, providing the uniform view of the data. And the availability means that all requests receive a response, regardless the state of any individual node in this system. And the partition tolerance refers to the system ability to continue serving and functioning despite of network failures. So this theorem states that in a distributed data service, we cannot guarantee all those three properties at the same time. So so like I said here, in order to achieve the high availability of data, you must have multiple copies. But writing multiple copies can lead the data consistency issue because you need to alternate across different servers. And if you need to do that, the data consistency issue can lead to performance problems. And for the consistency, we have three types of consistency. First, the weak consistency. It means there's no guarantee about the order about the updates order, and it means that the ordering the updates will be seen by different users, and it can. So different users may see different data at the same time. So there is no uniform data view. For eventual data consistency, it can assure that given the enough time, and we are assuming that the time is enough, and there's no new incoming updates, then all the data copies will eventually become consistent. This is most commonly used in the real distributed system, and as it allows for high availability and the partition tolerance. So it may take some time for all nodes to. It just takes some time, but the consistency is eventually be achieved. And the last one is the strong consistency. It behaves like just like a single server and single centralized server. So all users see the same version of the data at the same time, just like they just access one server. Usually, the weak consistency and the eventual consistency are generally achieved through the replication asynchronously. So, but the strong consistency is achieved through the synchronously replication. Asynchronous means better performance, of course, and but also it implies more complexity. And synchronous replication, on the other hand, has poor performance, but is much easier to achieve, to implement. This part, okay, this is about microservice, but actually I feel I just found that it's duplicated with the previous session shared by my colleague. So I will skip it quickly. So you can see that it just lists some pros and cons, and for pros is more flexibility, especially if you have a lot of business domains, business value chains, and it's much easier to control the scalability, and also the diversity means that you can develop different components with by different tools, different programming languages, as long as they use the same RPC protocol or communication protocol, then they can build us the same microservice system together. And the efficiency, actually, this depends by how does the microservice being designed. Actually, there is a good example. Recently, the Amazon Prime Video team, they post a tech sharing article, a blog, I remember, about how they reduce the costs by changing their architecture from the distributed system to a monolith application. So this is a good this is a typical example that states that which one is better. It depends. So in my opinion, the business actually the example in the Amazon Prime Video team's blog, their example is the business is very simple. It's too simple actually. So there's no, like I said, there is no perfect solution. It always depends on the business or on your future needs. No, so in their example, the efficient microservice efficiency is actually not good. Is worse than a monolith. But in most of complex business scenarios, I would say that microservice can handle efficiency issue more easier, or it can achieve acceptable efficiency easily. Yeah, then it's much easier than design and build a very complex, huge monolith application. I think that also explains the principles to choose which type of architecture. So first is about context. So it always depends on the context, your business context. And if you are not clear about your business domain context, you are not clear with your business boundaries, then I don't think you can make the right decision how to choose the architecture. And even if you adapt the microservice, how to divide your service or how to make sure how small, how often your microservice should be. And of course, it should be single responsibility. Each of the microservices should have single responsibility, but that depends on what responsibility, on which level we are talking about. So, but always remember, always keep your business transaction in the same microservice. Don't try to split the transaction logic into different parts as much as possible. Yeah. Okay. The next stress is about service mesh, which is also mentioned by my colleague, and yeah, this is about the service governance. The service mesh can help reduce complexity of communications in the microservice architecture, and it's mainly for the traffic management and security and observability, also known as the tracing system or logging system. And it also supports multiple cloud and hybrid cloud support. So it can help us connect different cloud platform together in a unified product or systems. So you can see why it called service mesh. You can see all those grids here. In this diagram, you can see the left part, the green part is the logic part. Is where you deploy your logic application, and the blue part on the left, on the right, is the mesh sidecar process. It takes the control of the communication. So all your traffic will go through the sidecar, and the sidecar will help you protect your traffic, and also help you route your traffic with the proper suitable governance. Yeah. Okay. Okay, I will pause to answer some questions. First, can it overload on the load balance if the requests are tremendous? Yes, every system, every service have a risk of overload, right? So, but load balance is designed to solve that, because like I said, actually there's no any business logic on load balance. So the logic can be very simple. The load balance system can just focus on the performance of network protocol, and so it's all about how to utilize the network device more efficiently. So it's much, because it doesn't have business logic, so it's much more stable than the business application. And also it can utilize the network machine in a fantastic efficient way. So usually in a real world, the load balance application has much has much redundant space to support more traffic. Yeah, actually, the open source project I just mentioned before, this is a good example how they design their load balance implementation based on, I mean, strongly combined with the specific Intel machine physical device architecture. Okay, next, wait, how is the sharding data replication? How is the sharding data replication? Actually, like I said, sharding is not strictly speaking, sharding is not a replication. It's just how we split data in different chunks, different servers. But usually it combine with it comes along with the replication implementation. So sharding is like read zero and mail. I would say yes. If you can say that, but yes, okay. If data is shard into multiple logical chunks and then stored into different database, residing in different regions, how exactly will data be retrieved since the data table is already split up? Good question. Yes, sharding is not just limited to the same database implementation, yes, we can shut user data into even in different type of databases, and usually it will usually this solution is not so common, but we do use that in some special scenarios. For example, if a database if the capacity of one database is not enough to support the expansion, to support scaling up, then we may introduce another type of database to support that. But if we're doing that, of course, the complexity of the system will increase a lot. So there always should be actually for this I just answer it in theory, not in just in real world, but it can be easily solved by introduce another data service layer, which wraps the implementation details of the different database. So your application layer can just communicate with those database layer with the data service layer to mask the different database to upstreams. Okay, how would you design a distributed file system given the constraints of TikTok high volume, high usage? Actually, I would say that I'm not a database expert. Actually, my colleague, who showed Oma, who showed the database course on Wednesday, can answer your question more accurate than me. I think more experienced than me. I think this this is a quite detailed question. I think we can discuss that offline. Just to clarify, so data mirroring is essentially ensuring all data centers contain the same data. How is it done? Yes, yes. How is it done? So in TikTok, actually, I will mention that in the following section. But simply in short terms, we just do the data replication asynchronously by some message queue. Yeah. What does logic application mean on the green color part? Okay, it means this is the you can simply it's just the code you developed. So yeah, it's just the logic code written by developers, and the right part, the blue color part, is the infrastructure which provided by the mesh sidecar. Is the service mesh the same as byte mesh? That was shared in the previous. Yes, byte mesh is an implementation of service mesh. So, for example, service mesh is just a concept term. Okay, the last one. Where is the open source data that you shared previously again? Open. Do you mean the load balance project? Is in the I think you are talking about this one. I'm not sure. Yeah, you can find it in the materials list posted on the main document. Okay, let me proceed. So the last part is about the practice in TikTok. So first is about the multi-IDC architecture I mentioned before. So there are three types of them. Firstly, the single IDC, which is like a monolith application architecture if we compare it to the microservice. And the second one is the dual active data center in one region. And sometimes we call it active architecture. And the last one is the multi-active data center cross regions. So in single IDC, it's very simple, of course, and everything is in one data center, and you use it to solve all the users across the world. And everything, every microservice and every database are in it. And the disadvantage is obvious that considering the RTT limitation, the performance is not so good for all the users. And also, more importantly, a single point failure can cause the system to be completely unavailable. So actually, an interesting example, a simple air condition malfunction in the data center can cause the service to be unavailable, right? Yes, it's a real case. It may sound unbelievable that we do have experienced a water leak incident in our data center in TikTok once. Very awkward, but yes, our server is suffered by the water leak. It is commonly, actually, single DC is commonly used in many setups, of course, and when the business have developed a certain stage, it can meet the following requirements anymore. And for the multi data center architecture, in this diagram, it shows that we have two data centers. Each of them have their own data replication. So the key of the multi data center architecture is all of them serves part of the users in the world, and for the users belongs to this data center. The data center is the primarily or the must data center for them, and the second one is just the backup. So all the write operations, all the writing data are performed across the IDC asynchronously. So if let's say if a user access the data center at the at the left side, then it's just the user only access the left side data center all the times, and he or she read the data from the left part, but all the writing data will not just the writing in the database belongs to the left IDC, but also asynchronously synced to the corresponding to another IDC. And but all the read operations, all the read requests are executed in local IDC. So this means that those two IDCs are peer-to-peer and can serve as each other's primary and secondary centers. And during the switch, let's say if we need to do the disaster recovery, the user experience is almost imperceptible, because user can quickly switch to another IDC, and they can access their data entirely and completely from another IDC. But this is of course an eventual consistency system. So if the disaster recovery takes some time, so we don't support the switch immediately, but maybe seconds, maybe minutes, then the user can access all the data synced from another IDC. Okay, so this is another diagram with much more details, and the key, you may find that the key is the data syncing part in the database layer in this part, and user can user only access the data center they are assigned to, and this data center is treated as the master server, and all the read and the write requests are routed to this specific data center. Yeah, but uh, the only thing we need to do is sync the written data asynchronously to other IDCs to support the high availability. Okay, this syncing logic is the syncing logic is kindly it's not actually, it's not so complexity if you stand at a high level to look at it. For most business scenarios, there are few conflicts when user data is replicated to a backup IDC, because that backup IDC won't be accessed by the user directly, which means that that backup usually can accept the data syncing without any conflicts. So so the performance is also acceptable. But of course, we do need a serious mechanism to protect the data syncing process, including the data validation and some compensation. Yeah, but still, it's not common or suitable for all business, but it should support most of the business that doesn't care about strong consistency. So every system design depends on the context. Okay, next is the multiple IDC architecture. So yeah, this architecture is more complex than the previous two. You can see that I list 3 IDCs here, and each of the IDC may serve part of the may serve part of users in the world, and usually they can serve an entire continent. As I mentioned before, when the data center are physically far apart, any cross data center request have significantly latency. So with multiple IDCs serve different regions or continent, the performance is much better than single IDCs serves far away users. And when there are too many copies of data, too many data replications, data consistency problem becomes more complex. Of course, such as a data loop problem during the during the synchronization, and the compliance requirements also may dedicate that the certain data must be stored in specific data center. A typical example is that we can the US users, they request to have a standalone data center, but in other, of course, we can't accept the cost to build a standalone IDC for each countries, of course not, but we do need we just serve as much as possible under the condition that we match all the compliance requirements from the different governments of different countries. Yeah, so multi-IDC architecture, the key of this architecture design is how to route users quickly and efficiently, and how to sync data with a lot of conditional requirements. When I say conditional requirements, I mean, for example, we do we can sync the public user post content out of any of the data center, even US, of course, because because the video posted by the US users, they can be viewed, they can be browsing by users in Singapore, in Europe, right? But for example, their IM data, their instant message data, of course, is definitely not allowed to sync out of the data center in US. So this is the business different. This depends on different business scenarios and the different compliance requirements. Okay, so this part is about how we handle the data consistency issue while syncing data communication across IDCs. So of course, eventual consistency is most widely and common solution for most ordinary scenarios. The three keys is first avoiding conflicts caused by concurrent writes. So we should it's very important to find a way to separate the writes in most small scope to reduce the concurrency probability. And the second one is ordered synchronization between IDCs. So if we maintain the data syncing in strictly or in order, then it's much easier to handle the to solve the performance problem and also the consistency problem. And the last one is building a proper data checking and repair mechanism. No system is no weakness. So we still need some compensation mechanism to assure that. Okay, the last topic is about modularization. This is a new concept that we maintain all the we pack all the business service into one basic unit, and this unit contains all the required microservices and all the necessary subset of for data, which means that if we pack everything into one unit, and once the unit is deployed in a new IDC, that means it can serve users belong to that IDC perfectly, and those it provides us first it has those advantages like the photo isolation between units is limited, so there's no impact cross modularization, and it's less stability impact on each country is caused by a throughput difference. For example, Indonesia has much large population than Singapore, right? So if Singapore and it's not a real example, but I just assuming that if Singapore users and Indonesia users are all served by one data center, but once if the throughput from the Indonesia users increased a lot, the fluctuation is enormous, which means that Singapore users might be affected. They may feel the overload of the system, but the traffic is not introduced by name. So if we can allocate users to different units and different proper units, we can reduce the risky of the impacts from each other. And for the efficient, of course, a basic unit is also easy to do the testing and the drill for some disaster recovery. And also, if the data in access and read and write in the single basic unit is more centralized, then the higher cache hit rate we can get. So the performance is it also can help improve the performance. And yeah, next is we can have few connection numbers in one unit, which can reducing load balance pressure. And yeah, and next is the high scalability. Just theoretically, the modularization can be scaled infinite, and of course, there is base condition that we can handle the. We do have the data replication infrastructure to support that. Yeah, and the last one is maybe is also very, very important, that unit deployment modularization can satisfy the local data requirements in some regions. It can match the geopolitics. Okay, sorry, I exceed some time, and yeah, the next part is disaster recovery, which is asked by some of you before. And yeah, I think I already experienced it a bit. So in this multiple data center architecture, we can easily support disaster recovery by routing the users from a failure IDC to another one, because each IDC we can treat it as a modularization unit, and it contains all the required subset of data that users that belongs to users. So in each so when the user is routed to another IDC, it will the users may experience a short time of data incompleteness, but after the switch is done, then user experience won't be affected anymore. So this supports this is relatively support the high availability for TikTok. And you may ask that if we can't support if we can't sync everything out of some IDC because the data syncing is conditional, how can we make sure that the data is exactly the same as the data center it was initially be written? Yeah, this is a good question. We can't assure that. So which means that in our architecture, we always have a replica data center, a backup data center in the same geopolitical regions. For example, even in US, we have 2 data centers to support that. Each data center can serve the entire US traffic. So which means we do have the redundancy to cover us during the disaster failure. And yeah, and this is for disaster recovery. I will just explain it in short terms. And yeah, those two topics is different. One is about the data center recovery, which means that the failure occurs in internally. Is the failure is in the data center itself. And the second kind of disaster is about the communication link recover, communication link failure, like yeah, I mentioned that before. For example, if the undersea fiber is broken down, which means that the data center, the communication between the data center is disconnected, and those is at this situation, we need downgrade the strong consistency functionalities when failure occurs, because we can't assure that anymore. But that doesn't mean that we can serve the users entirely, because in most business scenarios, we don't depend on strongly consistency. Like, for example, you browsing the video of TikTok, you post comments under the videos, all those fundamental features won't be affected, because the data it can just write in the current IDC, and all those data will be synced and replicated once the communication link is recovered. Okay, the last one is an example. Actually, I want to use it as an example how we pass the request across different IDC. You can see that in this diagram we have 4 IDCs, but I think I already express all the scenarios I want to share in this session. So I think we can skip that and save some time to answer the questions. Okay. Let me see. Okay, we have 3 questions here. One is, so if the standalone IDC in US is not synced with other IDC in other regions, does it mean I can't see TikTok videos are posted by someone? I think I already mentioned that. No, it's not. The data syncing between US IDC and other IDCs is controllable, and it depends on the data category. So for the public UGC content, user post content, it is allowed to sync out of US. But for example, for the private videos, yeah, it doesn't. It was not synced out of US, so the data is only belongs to US data center. Does modularization also mean that your collection of logs will have to scale accordingly too? Collection of logs. Sorry, I don't understand the question, but what I want to say that the modularization means that it contains all the components, all the middlewares, all the fundamental tools within it. So also including the log systems or tracing system. So yes, the log can be only accessed and read internally. How do you downgrade non-core functionalities? Can we have some examples? That depends. That also depends. Each different business domain in TikTok has their own downgrade strategy, and I can use TikTok messaging system as an example. So messaging system, we strongly depends on the keep live long connection, right? We use WebSocket to speed up the message delivery in real time. But what if the WebSocket connection service is down? Of course, we downgrade to HTTP connection. So in HTTP connection, we communicate with the end users. We communicate with the SDK running on users' mobile phone by HTTP protocol, which is not so real time than WebSocket, but it still support the fundamental features. We can still send in messages and receiving them. So this is one of the level of the downgrade strategy. And for some other and for some different failure, of course we have different downgrade strategies. Like the failure occurs in database, we may have some backup database or different kind of database, or even code backup database to support some core functionalities. And for non-core functionalities, that depends on the value of the business. If the failure is very seriously and is very severe, we may just give up some non-core functionalities. Yeah, the users may experience maybe some internal service occurring. Please wait a minute again, something like that. Okay, I think that's it. If there's,
I think Hani, you can just wrap up with some questions.
Sorry.
You can wrap up with some of the Q&A.
Okay.
Yeah.
Let me see if there is any questions in the chat box. No. Okay, I think that's it. If you have any more questions, we can communicate with offline in the lab group. Okay, thank you very much.
Yeah, thank you, Han Yu.